Hello and welcome to Applied Statistics using SPSS, and in this video I'm going to demonstrate how to do multiple linear regression in SPSS. And the dataset I've got in front of me is a dataset that I've created for the purpose of this video. So the dependent variable is FTSE, which is this column, and unemployment and oil are the independent variables. So the unemployment, this is unemployment rate, and oil, this is oil price in dollars. And the first thing I want to do is check the assumption of linearity. And in multiple linear regression, we must have linearity between the dependent variable and all independent variables. So in this case, there must be a linear relationship between FTSE and unemployment, and FTSE and oil price. And the way I will do this is by creating a matrix scatter plot. And in SPSS, this can be done by selecting graphs, then legacy dialogues, then scatter, then select matrix scatter and then define. And then we want to move across all the variables into the matrix variables box and click on OK. So here is our output. And we want to look at the relationship between FTSE 100 and oil price and FTSE 100 and unemployment rate, so essentially these two boxes in the first column. And we can see that there's a linear relationship between FTSE and oil price here and FTSE and unemployment rate, which satisfies the assumption of linearity. Okay, so to perform multiple linear regression in SPSS, we select Analyze, then Regression, and Linear. So as I mentioned, the dependent variable is FTSE, so I'll move this across to the dependent box, and the independent variables are unemployment and oil price. I will next click on Statistics. If the measurements were made in time, I would select the Durbin-Watson test. This would check that the residuals are uncorrelated. I'll also select Collinearity Diagnostics. This will check the no multicollinearity assumption of the multiple linear regression procedure. This is in fact the extra assumption on top of the assumptions for simple linear regression. And then click on Continue. And I'll next select Plots. I want to check that the residuals are normally distributed, so I will select histogram and normal probability plot. And I will also create a scatter plot of Z predicted versus Z residual. So this will check for the assumption of homoscedasticity, which checks that the variance of the residuals is constant at each level of the predictor variable. And it's also a double check of linearity, which have further assumptions of the procedure. So then select Continue and OK. So here is the output, and the first thing I want to do is to make some remarks about the assumptions. So if we first look at this box here, so the collinearity statistics, and in particular we want to look at the VIF column. So this is variance inflation factor. And the VIF score should be close to 1, but under 5 is fine, so these values are under 5, so these are fine, so therefore we've got the assumption of no multicollinearity. And if we scroll down, so this is the histogram of the residuals, and this looks approximately normally distributed, and also the PP plot. Here, all the values are fairly close to this straight line. So therefore we've got normality of the residuals. And then if we look at the scatter plot, so this checks for homoscedasticity and a further check for linearity, and what we're looking for is a random pattern about the line of 0 standard residual value, which is what we've got here. Okay, if we go back to the output, So the R-squared value is 0.938, so this indicates that 93.8% of the variability in the outcome is accounted for by the model. And then the ANOVA table, this is significant, so therefore we reject the null hypothesis. And the null hypothesis in this case is that the coefficients of the independent variables are 0. So this is further evidence for the suitability of the model. And if we go back to this table, so here are the coefficients of the independent variables, so unemployment rate and oil price. And we can also see that these are significant, which is further evidence for the suitability of the model. Okay, I hope you found this video useful. If you have any questions, please let me know.